We're currently on site at a 2-unit development in the inner east of Melbourne. This is Unit 2, which consists of strip footing and a timber subfloor. At this stage, we're inspecting the reinforcement prior to pouring concrete. This site previously benefited from some blinding, which has been poured due to the depths required to achieve natural soil. Through this section here, which is a strip footing, it's also acting as a retaining wall. Now at this stage we have a sleeper retaining wall behind, so there's no obvious retention required for a site cut because we already have one in place. So it's assumed that as the construction proceeds that there's going to be backfill up against this sleeper wall, and the retaining wall is going to actually be retaining fill. So what the engineer has called for in this instance, in this strip footing / retaining wall, is not conventional for a normal strip footing, in that he's called for a top and bottom layer of slab mesh, SL81. The one signifying the spacings in the grid being 10 centimeters, and the 8 being the gauge of reinforcement being 8 millimeters. The widths of these retaining wall / strip footings are 800 mil wide to a required depth of 500. This little section here is a pad footing incorporated into the side of the strip footing, and we'll see that again here, another pad footing which is picking up point loads. Additionally, there's pad footings internal to the subfloor area of the dwelling, which will also be picking up point loads. Again, this is signified as pad footing number 2, which calls for top and bottom SL81 mesh. In addition to some internal pad footings, we also have external pad footings, which are picking up posts for verandas, etc. Now PF1 has already got some blinding in it. It doesn't require any reinforcement. However, the design for this pad footing is also as per PF2, so we would expect some top and bottom reinforcement in this location, which is yet to be installed. The back of the dwelling, we've just got a conventional strip footing. Again, blinding was previously poured. Now there is some excess water in here, which is not ideal. You want to remove that. But pouring a mass footing like a strip footing, the water is likely to rise and be removed when the concrete is poured. Now in this section, the engineer has actually called this strip footing SF1 from the back section, which only required a 300 wide footing with 3 bar. But through this other side here, the engineer had called for SF2, which was a 450 wide strip footing with 4 bar top and bottom reinforcement. So the contractors have just continued that same width all the way through. Now typically that's not an issue, as the Australian standard says that if you widen by 100 mil, you add an extra bar of reinforcement in. So they've continued the 4 bar and the 450 wide strip footing throughout, even though some parts only required a 300 wide strip footing. Again, we've got some pad footings incorporated into the side of the strip footing here, with your top and bottom slab mesh, distinct from trench mesh being in the strip footings. And you've got your plastic membrane through the strip footings here, which is not typically required like it is for a slab on ground construction. Now back to the retaining wall section. The slab mesh is typically as per the engineering design. However, we also expect to see some vertical bars which are tied into this footing, which is then going to be tied into the vertical bars of the block retaining wall. These have yet to be installed, and they should be at 300 centres and 11 bars the engineers called for, with an L return or cog at the bottom of the reinforcement of 200 millimeters tied into this Rio. You can see an example over here on the retaining wall. This is a shotcrete retaining wall which has already been inspected and poured with concrete previously. This strip footing is associated with the garage, which will then have an infill slab later on. As previously discussed, we have some pipes in the trench which need lagging. Now we see that pipe has been lagged, but this one is yet to be lagged, which still requires lagging prior to pouring concrete. Obviously all litter, etc. needs to be removed, and chairing needs to be adequate. So in these instances, they need to be adjusted so they're adequately supporting the steel. Some of these pad footings, as I said earlier, still require reinforcement as per the design for PF2. And that concludes our strip footing inspection for Unit 2.